Write the equation of the hyperbola in standard form and graph the hyperbola. We have 9x squared minus 4y squared equals 36. Because we have the x squared part minus the y squared part, the standard form for the equation of the hyperbola is this first form, which indicates we have a horizontal transverse axis. Notice the right side of the equation is equal to 1, which indicates our first step will be to divide both sides by 36. On the left, we'll divide each term by 36. The given equation is equivalent to 9x squared divided by 36 minus 4y squared divided by 36 equals 36 divided by 36. Simplifying, 9/36 simplifies to 1/4, or if it's helpful, there's 1 9 in 9 and 4 9s in 36. Simplifying, we have x squared divided by 4. And then minus 4/36 simplifies to 1/9, or again, if it's helpful, there's 1 4 and 4 and 9 4s in 36, giving us y squared divided by 9 equals 1. This is the equation of the hyperbola in standard form. And now again, because we have the x squared part minus the y squared part, we know we have a horizontal transverse axis, which indicates the hyperbola is going to open to the left and the right as pictured here in our notes. The endpoints of the transverse axis, this axis here, are a units from the center, and the endpoints of the conjugate axis, this axis, are b units from the center. So what we'll do is plot the endpoints of the two axes, and then we'll sketch this rectangle. Notice the asymptotes pass through the diagonals of the rectangle. Once we sketch the rectangle, we'll sketch the asymptotes. We will sketch the hyperbola. Going back to the standard form for the equation again, the center is always the point h comma k. In our case, notice both h and k are equal to 0, which indicates the center C is at the origin. And then notice a squared is equal to 4, which indicates a equals 2, because 2 squared equals 4, and b squared equals 9, which indicates b equals 3, because 3 squared equals 9. So let's go ahead and plot the center, 0, 0. And now from here, we are going to plot the two endpoints of the transverse axis, which we know is the horizontal axis. The endpoints are a units from the center, and because a is equal to 2, one of the endpoints is 2, 0. The other endpoint is negative 2, 0. And now we'll plot the endpoints of the conjugate axis. The endpoints are b units from the center, and because b equals 3 from the center, we will go up 3 units to the point 0, 3, and then back to the center and down 3 units to the point 0, negative 3. These are the midpoints of the four sides of the rectangle, which we will now sketch. And now we'll graph the asymptotes, which pass through the diagonals of the rectangle. Notice we can use the rectangle to determine the slopes of the asymptotes. Notice the asymptote with the positive slope has a slope of 3/2, which indicates if we want to find additional points, we can start at the center and go up 3, right 2, as many times as we wish. And we can go back to the center and go down 3 and left 2 as well to find additional points on the left. Let's go ahead and sketch the asymptote with a positive slope. This also indicates the asymptote with a negative slope will have a slope of negative 3/2. Starting at the center, let's go down 3, right 2 multiple times. And then going back to the center, let's go up 3 and left 2 as well. And now we'll sketch the other asymptote. Remember, the endpoints of the transverse axis are also the vertices, which indicates one vertex is 2, 0. The other vertex is negative 2, 0. This is all the information we need to sketch a nice graph of the hyperbola, because each piece will pass through the vertex and approach the asymptotes. The piece on the right looks like this. The piece on the left looks like this. Let's look at a second example. We have 4y squared minus x squared equals 4. Notice in this equation we have the y squared part minus the x squared part, which indicates now we have a vertical transverse axis, and the hyperbola will open up as well as down. But we'll take the same approach. Let's first divide both sides by 4. The given equation is equivalent to 4y squared divided by 4 minus x squared divided by 4 equals 4 divided by 4. Notice by dividing both sides by 4, we will now have a 1 on the right side of the equation, which we need to have the equation in standard form. Simplifying, 4y squared divided by 4 simplifies to y squared, which I'll write as y squared divided by 1, so we have a denominator, minus x squared divided by 4 equals 1. Notice for the center, h is always with the x part, k is always with the y part, but in our case, both h and k are 0, which indicates the center is the origin. Also notice that a squared equals 1, which indicates a equals 1, and b squared equals 4, which indicates b equals 2. So again, going back to our notes, because we have a vertical transverse axis, the endpoints of the transverse axis are a units above and below the center, and the endpoints of the conjugate axis are b units to the left and right of the center. Let's first plot the center. And now let's plot the endpoints of the transverse axis, which again are a units above and below the center. Since a equals 1, one endpoint is 0, 1. This is also a vertex. The other endpoint is 0, -1, which again is also a vertex. The endpoints of the conjugate axis will be b units to the right and left of the center, and since b equals 2, one endpoint of the conjugate axis is 2, 0, and the other is -2, 0. Let's go ahead and sketch the rectangle. These are the midpoints of the 4 sides of the rectangle. And now let's go ahead and sketch the 2 asymptotes. By analyzing the rectangle, notice the asymptote with a positive slope has a slope of 1/2. We can go up 1 and right 2 as many times as we want, as well as down 1 and left 2. Let's go ahead and sketch the asymptote with a positive slope, which again has a slope of positive 1/2, which indicates the asymptote with a negative slope has a slope of -1/2. Starting at the center, we can go down 1 and right 2, again as many times as we need to, as well as going up 1 and left 2. Let's sketch the second asymptote. And now because we have the 2 vertices and the asymptotes, we can sketch an accurate graph of the hyperbola. The top part passes through the vertex and approaches the asymptotes and looks something like this. And the bottom piece looks something like this. I hope you found this helpful.